Hello, my name is Michael Hadges, and today I'll be comparing various machine learning approaches in the classification of quark and gluon jets. Machine learning is quickly evolving as a field. It has a lot of applications, one of which is classifying quark and gluon jets, and in this presentation, I'll show you several approaches that one might take to classifying quark and gluon jets. The first thing you need to know about is how to read an ROC curve. An ROC curve basically shows you how accurate an algorithm is. On the y-axis is how many true positives it has, the rate of true positives, and on the x-axis is the false positive rate. So ideally, you'd want the curve to go up to the top left-hand corner when the true positive rate is at its highest and the false positive rate is lowest. So our first classifier is the nearest neighbor classifier. What this one does is it puts all the jets into a matrix by how similar they are. And when it's looking to classify one of these jets, it grabs a bunch of neighbors and it asks how many of these neighbors are one classification versus the other. And with this classification, you can actually adjust how many neighbors that you're evaluating with any given query. For this ROC curve, we evaluated 500. Our next classifier is a multilayer perceptron. A multilayer perceptron is actually a type of neural network, which works a lot like our brain does. Basically, there's a bunch of neurons, and by strengthening and weakening the connections between those neurons, then we can make associations that help to classify jets. So we can associate some properties of the jet with the jet. Now, this next classifier is the naive Bayes classifier. It runs on naive Bayes algorithms, which are really complicated math equations that evaluate each pair of factors independently without any regard for how they fit in the larger picture. Now, that doesn't sound like it works well, but as you can see from the ROC curve, it gets a true positive rate of 0.8 and a false positive rate of about 0.25, which is actually pretty good. Something notable about the ROC curve is that it's not a curve. This is because of certain limitations with naive Bayes ROC curve generation. Basically, in order to generate an ROC curve, you need to be able to change classification thresholds, which the naive Bayes algorithm cannot do. So that's one limitation of it. Now, this next one isn't really a classifier. It's more something to have in your toolbox. It's called the stochastic gradient descent. It optimizes and improves accuracy. Here it's applied to a single layer perceptron, which is basically the multi-layer perceptron from earlier, but only a single layer of it. There are other algorithms that SGD can be applied to, but here I picked one that we were already familiar with. So this classifier is called the random forest classifier, and what this one does is it generates a bunch of decision trees by using subsets of the training set of jets that we give it. And then it runs any new jet it wants to classify through those trees, and whichever one the majority of trees come up with, that's what the jet is going to be. What a decision tree is, it's basically just a flowchart. There's a lot of similar things in a lot of different fields, but it's just a flowchart. Now, in terms of what the best classifier is, it's a three-way tie. Multilayer perceptron, it's a little bit behind, but there are things you could do to make it in line with the other three. I just didn't do them here for fairness sake. But naive Bayes and random forest, those are just about the same at their peak, which is 0.8 true positive to 2.5-ish false positive. Now, these sort of things can always be improved. One could normalize and align the data, which would help certain algorithms. Some algorithms are sensitive to the order of the data, so you may have to curate a special order. And some classifiers might be overfitted, which is where they're too trained on a single data set, so that when you try and expand their reach to another data set, it just doesn't work as well as some other less trained algorithms, actually. And those are my works cited. If you have any questions, I'm sure you could reach me through Slack. But otherwise, I hope you all have a good day.